Hi everyone, welcome to this episode of Keipert Labs. In today's video we're going to talk through the concept of volcanic eruptions. So going through what is a volcanic eruption, how do volcanoes form, what causes a volcanic eruption, as well as the two different types of volcanic eruptions that we encounter, and the effects on the environment. Okay, let's get into it. So we're thinking of the essential question, what makes a volcano erupt? How does this happen? Well, basically, firstly, we need to introduce two key terms, magma and lava. These two things are similar, but not the same. We're talking about molten rock, but the difference between them is where the rock is. So magma is molten rock, so rock that's been melted, that is below the Earth's surface. But as soon as that rock comes out of the Earth's surface, so it's at or above it, comes out into the atmosphere, we call it lava. Okay, so it's the same rock, it's just based on where it is that we give it that name. Okay, so we'll go through a little bit more information about what magma is. So this molten rock, this magma that's below the Earth's surface, collects in these things called magma chambers, okay, which can be up to 160 kilometers below the surface. They can be a long way down that they can develop. But basically, it's like this rock bubble that forms, okay, where this molten rock, which is where we're finding it because of where heat and pressure is enough to actually melt this rock. That then it actually kind of gets trapped in this kind of rock bubble. So with this solid kind of harder, denser rock around it that stops that molten rock from moving anywhere. Kind of gets trapped below and builds up pressure. Okay, so the sort of places that we find where there is enough heat and pressure to do this is at certain types of plate boundaries. So divergent plate boundaries and convergent boundaries. Not so much transform boundaries because they're not kind of pushing towards each other and creating lots of heat. They just build up energy in terms of the friction. And then also we can get these things that we haven't introduced yet called hotspots. Okay, like we've seen in terms of how Hawaii is formed, where magma gets brought up underneath the crust, even in the middle of a plate, and the pressure of it actually causes an intense amount of heat and pressure underneath the crust, and then we get some melted rock that forms there. Okay, for example, Hawaii is right in the middle of a tectonic plate, but because of a mantle plume, one of these plumes that's underneath it, that's how the volcano is formed there. Okay, so now let's look at, this is a bit of the structure of a volcano. So you can see the magma chamber underneath, where this magma has been built up and then trapped by the other layers of the Earth's crust. Okay, and it's making its way up towards the surface, and once it breaches the surface, that's what we are calling that as lava. Okay, so we've got this classic sort of cone shape in this diagram. There are other shapes to volcanoes that we encounter, and so we can see how that's sort of built up and where the magma comes out in the form of lava. Okay, through these side vents, and we're also getting this central vent in the middle here, the big kind of gap. And then we're seeing up here from a classic volcanic eruption, lots of dust and steam and ash that's forming out here. We're getting lava. We're also getting these big chunks of rock called volcanic bombs that are being shot out of the volcano. And the whole volcano itself is actually being built from layers of the rock that formed from previous eruptions. And so depending on how runny that rock is, will affect the sort of shape that volcano takes. Okay, so let's look at the three main steps that lead up to an eruption. Okay, so the first thing that happens is the mantle rock melts, okay, due to that heat and pressure, and then that magma collects in these magma chambers. It's built up in this solid kind of trapped sort of place. But as it becomes hotter, what it does is it expands. As it gets less dense, it kind of pushes out and away, and so then that's going to mean that it actually rises up towards the surface. And so then it's going to, wherever there may be cracks or weaknesses in the crust, that the magma is going to break its way through to the surface. It's exploiting those cracks. And so then as it gets to the surface, as it pushes its way through those cracks, we say that it erupts. And then depending on exactly kind of the nature of where this is and how it happens, this may be a gentle reaching of the surface, a gentle or non-explosive eruption, or it may be explosive. And we're going to go through those two things now. Okay, so the first type that we're thinking about here, and you can write on your sheet, is about explosive eruptions. So the key things that we want to be aware of here is that we've got an incredibly powerful eruption. We're getting massive clouds of volcanic ash that's forming, which is actually often more damaging than any lava that's produced. And some explosive eruptions involve very little lava, but just incredible amounts of ash. Okay, we're getting chunks of actually volcanic rock going high into the atmosphere, and about 10,000 times as powerful as an atomic bomb. So an incredible amount of energy that's involved in this explosive boom, eruption. Okay, and the reason it becomes explosive is that we're getting gases forming underneath the surface. Okay, so there's two sort of things that can happen there. We're mixing hot magma with water to make steam, and then certain types of rock also will produce carbon dioxide gas as they melt. They change, they contain, they're called carbonate minerals. And so they turn into carbon dioxide gas. And that builds up underneath the surface. That pressure grows like shaking a champagne bottle until eventually it must be released. The pressure's too much and it explodes. Okay, so it's a classic Mount Vesuvius at Pompeii, sort of situation, or Mount St. Helens in 1980. Okay, so we'll skip over that. You can watch that back later if you would like. But so we get massive clouds of volcanic ash. Okay, so lots of that rock that, because of the explosion, it puffs on out, and we get these tiny little fragments of rock that are really, really small and very light, very low in density, that go many kilometers up into the sky. And so often what we would see would be like a typical mushroom cloud from a nuclear explosion. And it just, because of the low density, because they're so hot, they just keep expanding and they keep moving their way further and further up into the atmosphere. And then if they're really, really small, they may not actually sink back down again. That's what happened in Iceland in 2010. There was a massive volcanic eruption and the ash clouds persisted for weeks and it disrupted air travel all over Europe. Okay, we also get what's called pyroclasts, these hot fragments of rock, these chunks of the volcano, chunks of material that form because we're getting hot kind of lava that's being pushed out of the volcano going up into the atmosphere where it's cold. And so what it does is you get this gooey kind of lava that's been shot out into the air that cools very quickly into hard rock and then falls back down again. And so we often refer to them in terms of these volcanic bombs, these chunks of rock that get shot out like the cork out of the bottle and then come down back to Earth. And we also, but the combination of these two, the ash and then the pyroclasts, depending on where they go and how they proceed from the volcanic eruption, if they sink down, then we call it pyroclastic flow. So where it's actually all this ash and it's moving sideways across the land, kind of as it's sinking down, and that can be incredibly devastating. In all likelihood, that's what destroyed most of Pompeii in the eruption of Vesuvius in AD 79. This intense kind of waves of very, very hot ash. It just burns everything to a crisp in one go. Okay, so now we're going to talk about the second type, or what we call gentle or non-explosive eruptions. Okay, the reason they're non-explosive is there's little to no gas that's being formed in this situation. We've just got lava. Okay, and then often this is happening because the lava is thin, fluid, and runny. So it's not really thick and sticky and viscous, which we would use for the really thick kind of lava that doesn't flow easily. So this lava, where it comes out, it kind of oozes out and flows over the ground like an incredibly hot river, has several hundred degrees Celsius or up to 2,000 degrees Celsius. Now, with eruptions like this, there's generally a lot of warning, which means they're much less deadly because you know that they're coming. You can see the flow of lava coming down from the volcano, and so then you have much more chance of getting people out of the way. Whereas an explosive eruption, where if it just goes, then you may not realize until it's too late. Okay, but it's still very destructive to property and the landscape, the environment, because there's very few ways of actually stopping this kind of a lava flow. It may stop if it makes its way down to the sea where the rock kind of cools down, or if you can have some sort of a technique to actually cool the rock down after it's been flowing, you may have a way to divert the lava or to actually do that. There was a story about a town in Iceland where they were able to do this. The eruption was happening and they managed to, by pumping water from their harbour, they were able to basically spray it onto the lava such that then it actually cooled down enough that it started to set, and then that rock barrier was kind of enough that the other lava wasn't able to push through it, and it kind of diverted it, like if you were changing the course of a river, or changing the course of floodwater so that it went past the town. Okay, but it's a very difficult thing to do, and so even though you can get out of the way, there's maybe not much you can do to stop the damage. And so here's a photo that you can see a lava flow going from the right to the left of the image, and so then they've got these houses that are being moved out of the way to get out of the way of that lava flow. But you can see that now this is relatively cold lava because it's black. as opposed to like white hot lava where it may be 2000 degrees Celsius or more. But this is still well and truly hot enough to burn its way through the road. This is actually the asphalt or the bitumen on fire, as that lava is hot enough to heat it up to that temperature where it will burn, and as it's carving its way through. And then you can see that this is obviously somewhere near the ocean. Perhaps it's somewhere like Hawaii, where it's actually moving its way through. Now, these men are, obviously it depends on the perspective of the photo as to exactly how close they are. They would be very hot, like that would be quite hot, depending on how close you get. But they could stand there quite safely, being able to predict where that lava would flow. Okay, let's look at these to finish things up. Let's look at the environmental effects of an eruption like this. So the ash up in the atmosphere can be very dangerous. Okay, it can stay up in the atmosphere for years even. Okay, it can change, it can block out sunlight, which is then going to potentially change weather patterns and affect the temperature of the Earth. Okay, so changing weather patterns in terms of cloud formation, you get really beautiful sunsets, so it would look really nice, just like if there's a bit of bushfire, you get that beautiful kind of orange sunset, but it's not a good thing. And in a really significant eruption, like in Krakatoa in the 1880s, that it dropped the global temperature by about 2 degrees, the average global temperature for the next 3 or 4 years, because of that eruption and the ash that was in the air. The volcanic gases are also very dangerous because they can form poisonous invisible clouds, maybe hydrofluoric acid or sulfuric acid clouds that can kill all manner of things, living things, plants and animals, humans. Okay, and they may be very toxic if it's close to the eruption. And then some more long-term kind of damaging things, production of acid rain, where sulfur dioxide is one gas that's often produced by volcanoes. Dissolving in the rain makes a sulfuric acid rain, and so that can damage a whole lot of living things in the long term, changing the acidity of things like rivers and lakes around areas where an eruption has happened. And also it can destroy ozone in the ozone layer. The presence of the ash and all those things can disrupt that. Okay, so we've looked at the difference between magma and lava. We've looked at the steps in a volcanic eruption, as well as then going through the two types, explosive and non-explosive, and then some of the environmental effects. All right, thanks very much for watching. Bye for now.